permutations, which is the number of ways things can be arranged, but permutations with repetitions and permutations that are circular. So permutations with repetitions. So if some objects in a selection group are the same, such as in wiggle there are 2 G's, then there's no difference if I switch those two. So if one G is in the first position and one is in the last, and I switch them, the arrangement does not change. So the number of permutations when there are repetitions is less than the number when all the objects are unique. So in a permutation with repetitions, n factorial, n is the number of objects total, p factorial, q factorial in the denominator, so it's anything that repeats. So here's an example. In the word mom, how can we rearrange the letters? So there are 2 m's, but there are 3 numbers total. So n equals 3. So 3 factorial over, and since there are 2 m's, 2 factorial. And we can solve that on the calculator. 3 factorial, math probability option 4, divided by 2 factorial, so math probability option 4 is 3. There are 3 ways to rearrange these letters. Okay, how about in the word Illinois? So in Illinois, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters. So N is 8. There are 1, 2, 3 I's. And there are 2 L's. And those are the only repetitions. So we've got 8 factorial over 3 factorial times 2 factorial. Now, if we're going to put this in the calculator, we're going to need to put that denominator in parentheses so it does that multiplication before dividing. So 8 factorial divided by, parentheses, 3 factorial times 2 factorial. Close parentheses. There are 3,360 ways to arrange the letters in the word Illinois. In the word repetition, repetition has 10 letters. 2 of them are E's. 2 of them are T's. And 2 of them are I's. So we've got 10 factorial over 2 factorial times 2 factorial times 2 factorial. Okay, when I put that in the calculator, I've got 10 factorial divided by 2 factorial. And since I've got 3 of the same thing I'm multiplying down here, I could raise that to the 3rd power. So instead of 2 factorial, 2 factorial, 2 factorial, I'm doing 2 factorial cubed. There are 453,600 ways to rearrange the letters in the word repetition. Okay, so now I'm dealing with numbers. I've got 1, 2, 3, 4, 5 different numbers, so n is 5. 3 of them are 5s. So I've got 5 factorial, because there are 5 numbers total, over 3 factorial, because 3 of them are the same number. 5 factorial divided by 3 factorial. There are 20 different ways to arrange those numbers. Okay, arranging 7 marbles, so n is 7, 3 of which are red, 2 are blue, 1 is white and 1 is green, so white and green are not repetitions. So I've got 7 factorial over 3 factorial times 2 factorial, and I'll put that in parentheses. And there are 420 ways to arrange those marbles. All right, so all of the permutations we've done so far, the ones today with repetitions and others that didn't have repetitions, have been linear. Now we're going to talk about circular permutations. Okay, when things are arranged around something, that is a circular permutation. Here's just some visual examples of permutations, circular permutations of A, B, C, and D. But some of them are actually equal to each other. For example, A, B, C, D. Number 1 is the same arrangement as number 2. A, B, C, D. Same order, both clockwise. Okay, so those two right there are the same circular permutation. Number 3, A, B, C, D, it's not the same order. Number 4, A, B, C, D, not the same order. Number 5, A, B, C, D. That is the same order. Number 6, A, D. Now if I go the other way, A, B, C, D. But it's not the same order because it's going the opposite direction. So that one's a different permutation. Number 7, A, B, C, D. That's the same. And number 8, A, B, C, D, different order. So 4 of those are exactly the same permutation. If you shift around the table, but every one stays in the same spot, that is not a different permutation. So to do a circular permutation, there's 2 options. It's either n factorial divided by n or n minus 1 factorial. It means the same thing. Say the number is 5. 5 factorial is 5 times 4 times 3 times 2 times 1 divided by n. Cancels that out. If I do n minus 1 factorial, that's 5 minus 1 factorial. 5 minus 1 is 4, so that's 4 times 3 times 2 times 1. Those do exactly the same thing. So 4 people sitting around a square table. I don't care if it's square or what shape it is. The fact is they're sitting around. So this is circular. And that would be 4 minus 1 factorial, which is 3 factorial. So 3 factorial, 3 times 2 times 1, that's kind of a simple one, is 6. There are 6 ways to arrange 4 people around a square table. 5 cars sitting in a lane at a red light. They're not around anything. That is linear. So we'll do that as a linear permutation. 5 cars to choose from. Choosing all 5 of them. How many different ways could they be arranged? 5. Math, probability, option 2 for a permutation using all 5. There are 120 different ways that these 5 cars could be arranged in a line. 27 shirts hanging on a round display rack. So they're hanging around this rack that is circular. Okay, so that's 27 minus 1 factorial, or 26 factorial. That's a lot of different ways. So approximately 4.03 times 10 to the 26th power. Okay, so I've got 9 digits right here. I would have to go a whole lot farther, filling in a lot of zeros. This is a very large number. But that's the number of ways that you can arrange those 27 shirts around a display rack. 4 nurses rotating shifts. So if you've got nurse 1, then 2, then 3, then 4, it kind of appears linear, but once that 4th one is done with his or her shift, the first one is coming back. It's rotating. Okay, so rotating means this is going to be a circular permutation. So 4 minus 1 factorial. That's 3 factorial again, which we've already done. 3 factorial, 3 times 2 times 1. There are 6 different ways to arrange them circularly. And 4 doctors waiting in line at the cafeteria, just waiting in a line, not around anything. This is linear. Okay, so that would be a linear permutation. 4 doctors using all 4. 4, P, 4. There are 24 different ways that they could be standing in this line.